Hey there, and welcome to help video number 1 over our test premiere unit 8. This is 8-20, the objective part. This is our first part of the test premiere. Remember, as we go over these questions, if there's anything that is not cleared up by the help video, don't hesitate to email me the number of the question and we can set up a meet or whatever we need to do to make sure that you're understanding. And let's dive into it. Here we go. Question number 1. Which of the following chemical reactions is incorrect? Let's take a look at this first reaction. This is a decomposition reaction. We have one compound falling apart into one or two or more products. And this is specifically the decomposition of the chlorate ion ClO3. When the chloride ion decomposes, if you remember, what happens here is the oxygens all break off. The oxygen atoms all break off and form oxygen. And when the chlorate ion decomposes, none of the oxygens stay back with the original salt. Our salt is LiClO3, that's lithium chlorate. None of those oxygens, this oxygen should not be there. All the oxygens break off, as we see off here to the right. This is the correct way that this reaction happens. So, when we're looking over here, when the lithium chlorate decomposes, we would have 2 times 3, 6 oxygen atoms breaking off. Those 6 oxygen atoms join up to form 3 molecules of O2. This is the correct decomposition of a chlorate ion. And letter B, this is in fact correct. This is another decomposition reaction. These are in 8-5. And there were several decomposition reactions where you had to learn the pattern for, and this is the second one. Letter A was the first one. But when the carbonate ion decomposes, one of the oxygens does stay back in the salt, and the other two leave with the carbon to form CO2. When we did our video lab of decomposition reactions, they can prove the carbonate ion decomposes into carbon dioxide and oxygen by inserting a burning splint into the reaction test tube, and the splint would go out. That is one way, because carbon dioxide causes the extinguishing of flames. The other way you could test that carbon dioxide comes off this is with the lime water test. Whereas CO3 is decomposing, you bubble that gas coming off of it and send it through lime water. If the lime water turns cloudy, that means that CO2 is joining up with the lime in the water to form the carbonate ion, which is not soluble, and you see a white precipitant forming. That's why lime water can be used to verify the production of carbon dioxide. In this reaction up here, how did they prove that oxygen was produced in our video lab? One way is to blow out a burning splint and insert it into the test tube. And if that splint reignites, you know that pure oxygen is coming off that. The other way they did it was with the active combustion of sugar. You can throw Skittles into the test tube, and if they just essentially explode into flames, you know oxygen's coming off that reaction. Or if you throw gummy bears, they've done gummy bears in there as well, and you can tell oxygen's produced in the reaction if you throw gummy bears in the reaction and you see them just ignite and begin combusting. Letter C here is a single displacement reaction. Magnesium's an active metal, and it's put into a solution, aqueous solution of hydrochloric acid. So there's H pluses floating around and there's Cl minuses floating around. HCl is one of our 6 strong acids. It decomposes or deionizes or dissociates 100%, which means we have H pluses floating around. When you drop that active magnesium in there, it forces hydrogen, a less active element, to take those electrons. So the hydrogen started off as plus. Each hydrogen, there's 2 hydrogen H pluses here. Each hydrogen takes one of magnesium's electrons. Magnesium's dumping 2. So now the hydrogens each have 1. So to satisfy the duet rule, they join up and form hydrogen gas. Magnesium displaces the H+, it dumps its electrons, so it's now floating around as Mg2+ in solution. The chloride ions did nothing. They were Cl- here, they're still Cl- here, and remember that 2's there because we crisscrossed the 2+ from magnesium and the 1- from the chloride. So this is the correct single displacement of hydrogen ions from solution. Letter D is showing the combustion reaction. In a combustion reaction, we have a hydrocarbon, we have oxygen, and that oxygen's joining the carbons. It's splitting apart the C's and the H's, and it's joining the hydrogens to form water. So in a combustion reaction of a hydrocarbon, you end up with CO2, carbon dioxide, and water, H2O. If you notice, this combustion reaction could also be classified as an oxidation reduction reaction or redox reaction, because oxygen's oxidation number here is 0 because it's in elemental form. Over here it's -2. Over here it's -2. So the oxygen went from 0 down to -2. It was reduced, making oxygen the oxidizing agent. Who did the oxygens oxidize? The carbon. The carbons over here get their number because they have a higher electronegativity than hydrogen does. So carbon goes from its number all the way up to, it's oxidized from its number up to, in this case, +4, because the oxygens are -2. We've got 2 of them making carbon +4. It went up. In our last reaction here, we have also another one of our single displacement reactions. This time it's displacing essentially hydrogen off of a water molecule. This is H2O. It could also be written as HOH. And if you look at what's happening in here, we have HOH essentially. And this strontium right here is displacing hydrogen off HOH, causing the formation of H2 gas. The OHs stay behind. There's the other OH. So strontium is replacing hydrogen on a water molecule, single displacement or replacement reaction. And this is what it would actually happen. Active metals can replace hydrogen on a water molecule. We continue on, page 1. And here we're going to be looking at a series of 3 reactions, and we're going to try to identify an unknown metal. That unknown metal is one of these 5 metals, or one of these 5 substances. It's either iron, or 4 metals. It's either iron, cobalt, tin, or copper. We're trying to prove which one of these metals it is. So they're going to do a series of reactions. In the first reaction, they drop the unknown metal. Again, it's either iron, cobalt, tin, or copper. They drop the unknown metal in a solution of iron. No reaction occurs. What we can learn from that is the unknown metal is less active than iron. However, it could still be iron because a metal cannot replace itself from solution. A metal cannot force an ion of itself to take its electrons. So what did we learn by dropping this unknown metal in a solution containing iron ions? No reaction occurred. What we learned was essentially nothing. It could still be iron, but it could also be cobalt, tin, or copper. It's still one of those 4 metals. We learned nothing. In reaction 2, they drop the unknown metal in a solution of hydrochloric acid. A reaction occurs. In other words, this unknown metal forced hydrogen ions out of solution, causing the production of hydrogen gas. A reaction very similar to this one right up here, except in this reaction right up here in letter C from number 1, it was magnesium displacing it. In this case, the unknown metal's displacing hydrogen. What does that tell us? Our unknown metal is more active than hydrogen. So we know our unknown metal is more active than hydrogen. Hydrogen is more active than copper. So in this second reaction, we can immediately discount that it's hydrogen or copper since it's more active. So from reaction 2, we've narrowed it down to tin, cobalt, or iron. In reaction 3, they drop a piece of cobalt metal in a solution created in reaction 2. Well, in reaction 2, what solution was created? We had hydrochloric floating around, but what happened is this metal replaces the hydrogen ions, so now we have iron ions floating around. Cobalt metal's dropped into the solution that now has iron ions in it. Whoops, I said that wrong. The unknown metal ions are now floating around. Reaction 2, the unknown metal ions are floating around in solution because the unknown metal replaces the hydrogen ion. So now they dropped a piece of cobalt metal in a solution containing the unknown metal. A reaction occurs. That means cobalt is replacing our unknown metal. Sorry for all of a sudden talking about iron. It wasn't involving iron. Our unknown metal was floating around in the solution created in reaction 2. They dropped cobalt in it. Cobalt replaces that metal. So what did we learn in reaction 3? That cobalt is more active than the unknown metal. Iron is more active than cobalt. So we now know that our unknown metal is tin, Sn. In reaction 2, we eliminated hydrogen and copper. In reaction 3, we eliminated cobalt and iron. That leaves us with tin. Number 3, we have the activity series from the halogens. Fluorine's most active, then chlorine, then bromine. Iodine is least active. Knowing that fluorine's most active, iodine's least active, they want us to predict what would happen if we bubble fluorine gas into a solution containing potassium bromide. That means potassium ions are floating around and bromide ions are floating around. Well, we know that fluorine is more active than bromine. So fluorine, nonmetals, will replace a nonmetal. Fluorine's more active than bromine, so it's going to replace the bromine in solution. What ends up being the equation? This one right here. Take a look. Fluorine is replacing the bromine. Fluorine replaces the bromine here. So now floating in around solution, we have potassium fluoride. Why don't we put a 2 after fluorine here? It's because potassium has an ionic charge of 1 plus, fluoride's 1 minus. We crisscross 1 and 1. We put a 2 after this bromine because bromine is diatomic the same as fluorine is. So this equation is balanced, and this is what happens. A nonmetal will replace the nonmetal. In number 4, what's going to happen if we drop iodine in a solution containing sodium chloride? Well, iodine is the least active of the halogens. Iodine, if it's less active than chlorine, cannot replace it. So what ends up happening is absolutely nothing. We would have no reaction. That takes us through number 4. We're going to stop the video and we'll pick up with number 5 and 6 when we come back.